right, so that's the basic idea. Let me mention one other thing regarding circular motion, uniform circular motion, where you have a constant speed, not constant velocity. I think you know that by now. So if you have motion in a circle, then you know that law of inertia says if your object had no forces acting on it, then it would tend to move in a straight line at constant speed. Right? Moving in a circle is clearly not doing that, so there must be forces acting on it. So even though it's moving at a constant speed, its velocity is not constant because it's changing direction. Therefore, there is an acceleration, and therefore there is a force. So if the object were here and it were suddenly let go, then it would be moving in that direction. In order to make it not go this direction or that direction, I need a force pulling it back towards the center. So you can see that when you have, say, a rock on the end of a string and you twirl it in a circle. The force holding it in the circle comes from the tension in the string. Tension pulls both ways. It's pulling outward on my fingers, but inward on the rock. So the rock is being pulled towards the center of the circle, and if the string were to suddenly break, then it would now proceed, well, according to gravity, right, in the parabolic arc that you've been studying. All right, free body diagram for circular motion, though. For something, say, in orbit around something else, so like if gravity is the only force, like you have a satellite around the Earth, or a moon around a planet, or a planet around a star, then there's only one force. You hardly need a free body diagram, right? If you have something, say, on the Earth, where, especially if the motion is in a horizontal circle, and then you have gravity acting up, and gravity acting down, then you need to be able to show those forces. So looking at the circle from the top is not going to work. You need to look at it from edge on. So this is if I suppose that my velocity is clockwise, and this is a top view, then what I want to do is turn this edge on and look at it this way, so that my object is here and the center of the circle is over here, and the motion will be into and out of the board. So then suppose that this were a car that's driving in a circle, right? Car. I can pretend to draw a car. All right. So what are the forces acting on the car if the center of the circle is over here and it's driving along the ground and it's heading into the board and we're looking at it from behind, right? So you know that it has weight, so the force of gravity is acting on it. And you know that it's being supported by the ground, so there is a normal force, and you know that those are equal and opposite because the car is not jumping up and down here. No acceleration vertically. So, okay then, the car is turning, right? It's moving in a circle, and the center of the circle is over here, so there has to be a force in that direction. What is it? It's the force of friction between the tires and the road. That's what it is. So this is a frictional force, and the car is not sliding. It's so this is actually static friction. When you study rolling, you'll learn that rolling involves static friction, not sliding friction. So this is a force of static friction, actually. And it's moving, and it's accelerating the car towards the center of the circle, which simply means that it's keeping it in the circle. Right? So here it's easy to just do a typical XY kind of coordinate system. And in Newton's second law, in the y direction, you just have normal force minus gravitational force. So Fn is going to equal to mg. Right? In the x direction, you only have the frictional force. Now, any force that points towards the center of a circle is called a centripetal force. Centripetal meaning center seeking. That simply describes the direction. So if there's uniform circular motion, there needs to be a centripetal force, but what causes that centripetal force? It could be gravity, it could be tension in a string, it could be friction, it could be any number of things. It could be a combination of forces. So here, your net force in the x direction would just be the frictional force, and the acceleration is going to be the centripetal acceleration. So in this case, it would be my frictional force, and that's going to be related to my normal force through the usual relations. And then the acceleration is the centripetal acceleration, which is the v squared over r that you learned about. So, and then of course in the y direction you have these two. So that's hopefully enough to get you going through the exercises that you were assigned to do. Have fun!